This is our fifth talk of the day, and Josh is going to be talking to you all about flying planes for skydivers. And so, Josh, it is all over to you.
All right, so for those who don't know me, my name's Josh. I'm one of the pilots at Langer, so I was asked to talk about aircraft stuff. But I'm going to talk about some other stuffs as well. So let's see how it goes. Before I get into that, I'm just going to talk about some of the stuff we've got coming up at Langer this year. So here's some of the events we've got on the cards. There's lots of stuff on there. The good thing about this lockdown is we're still in January, so hopefully we're not going to miss too much like we did on the last one where it was perfect blue skies every day. So keep your eyes on the events. Here's some of the stuff we've been working on this lockdown. So the cafe is getting a little bit of a facelift. Here's Dan doing something in the corner. He's working on putting this little log burner in this for us, which should keep the bar a bit more cozy. Some of you spotted Dave Epton up on the roof earlier, so he's up there trying to waterproof it. Sometimes people don't realize the amount of work that goes into trying to keep a World War II building serviceable. So if you're ever going to a drop zone, have a look at their buildings and feel a little bit sorry for them. I wanted to talk briefly about the AGM this morning. I don't know how many people tuned in it, but probably quite a few. Some of the statistics, actually, it was the first time we've seen them, and it was a little bit shocking in some ways, not in a bad way. It was just surprising. I didn't realize quite how impacted British jumping had been, and the amount of licenses, the amount of tandems, the amount of new memberships. This graph stuck out to me. It's the amount of new A licenses that had been issued in the UK this year, down from 736 last year down to 121. One thing I was really proud of at Langer this year is the amount of A licenses we managed to issue. And I know there'll be some of our new jumpers in here and also some regular jumpers that noticed all of them coming through. So that was really cool. And I think a lot of that is down to and kept jumping with the guys and making them feel welcome. And also jumpers to jump with them and make them feel welcome at our drop zone and talk to all the new guys coming in and make them feel super welcome. Some of the guys do that because it's their job, and some guys do it just because they love jumping. And a little bit similar to that, the guys that organized this event today, not all of them work for us, some of them work for us, but they're not doing it because it's part of their jump. They're doing it because they genuinely really love Langer. And I think that's what makes Langer really special, is there's people willing to go the extra mile for us. So I just wanted to say thank you briefly to the guys that put this together for us, because I think it's a really cool little event. So the things I'm going to talk about, I'm firstly going to talk about exit separation a little bit because I was asked to talk about that. So we'll just dive into that. And I'm also going to talk about electric planes. I'll come on to that later, but some of you guys might have tuned into Pete Allen and Brian's talk the other day. They were talking about sustainability, and electric planes comes up quite a lot. So I wanted to talk about that, and from a jump pilot's point of view, about electric planes. So exit separation, and the reason I wanted to talk about it is I think it's something we could actually do a little bit better at Langer, and not also always super hot on knowing what the separation should be, knowing what factors are going into it and change as jump masters. The goal of exit separation is to achieve a horizontal distance between jumpers open their parachute, not when they're in free fall necessarily, but when they're opening a parachute, we want them to be far apart from each other. And that's that's ultimately so we avoid canopy collisions and near misses as well. Having a near miss with someone when you're close to them under canopy is pretty scary, and the guys that have got a few jumps in the air out of view, and it's not something you really want to do for fun particularly. Here's a picture of some static line jumpers jumping out of a military plane, and they don't have much exit separation. I've put that there to highlight the fact that you don't actually need exit separation apart from the fact that our parachutes are moving forwards. So it's the fact that our parachutes are moving forwards that mean we need to separate ourselves at the point that our parachutes open. So these two parachutes in this picture, they're opening there, and if they open moving towards each other, then they have a certain amount of time before they're going to have a collision. Here's what a canopy collision might look like, just in case you couldn't imagine it. That one's quite a pretty photo. So how much distance? And that all depends on how much time you want to react when you open your parachute. So you open your parachute and you basically get to choose a certain amount of seconds you want to be able to react. And the same for the person in the next group along before you're going to impact each other. And it's not an arbitrary choice, but it is a choice we can make when we're choosing how much separation we want to leave between groups. So hypothetically, let's say our canopy has a forward speed of 50 feet per second. That's about 35 miles per hour, which is a fairly fast parachute actually, but not unreasonable with modern parachutes. Now, if you wanted to have 10 seconds to react to having a canopy collision, you would need 1,000 feet horizontal separation when you open your parachute from next group along. So this is a choice we can make. Do we think 10 seconds is an appropriate amount of time to be able to react? Does anybody think that's too short of a time? Too long of a time? Not much reaction out there. So I think it's probably an adequate amount of time, 10 seconds, to be able to react to someone coming towards you. And that's about 300 meters. So there's a lot of numbers out there. You don't have to remember them. I'm just making a point. So let's remember 1,000 feet horizontal separation for this group, or about 300 meters. Now, what happens when you start to have groups? Now, a basic kind of group, a four-way belly group. If we have two four-way groups, if everyone's tracking 300 feet from the center of their formation, or about 100 meters, well, what you started with, your 1,000 feet exit separation, is now reduced to 300 feet upon opening our canopy. It's not very good maths, actually. It would actually be 400 feet. But we've reduced our opening separation anyway, and we've reduced it down to now only having 3 seconds to react. So obviously, if we have groups, we need to be leaving more exit separation, because we're going to track at the end of our jump and reduce our opening separation. And the more you track, the more exit separation you're going to need to maintain your opening separation. So to get back to our 1,000 feet opening separation, if we're all going to track 300 feet, then we need 1,600 feet, or about 500 meters separation on exit. So we had 1,000 feet for solo groups. We're up to 1,600 feet for small groups, and that increases more as you get into bigger and bigger groups. It's hard to actually find places that specify a distance on the internet if you look at different associations or different places. But the USPA do say 1,000 feet for solos and 1,500 feet for small groups. So that's probably a good number to work to. Why don't we leave longer? Why don't we just leave a minute or 30 seconds? Then we'd have loads of separation. There'd be no chance of hitting each other. Well, let's say we had 10 solo exits and everybody gave each other 300 meters separation, which is the distance we agreed for solo exits. That would give us a 3,000 meter jump run, or 3 kilometers. which is 1.6 nautical miles. Now, some of the more experienced guys might have looked at the GPS a few times on their ride to altitude. And 1.6 nautical miles is not unreasonable for the full length of a jump run. That's about the limit where you'd want to be getting to. So just to give you an idea what that looks like, if we started dispatching people overhead Langer there, and we had 1.6 nautical miles to get everyone out of the plane, that's about how far away the last group would be. So that's about the limit of what you'd want to push it to. Any further than that, and the last person is going to start risking not being able to get back in time. So that was 10 exits at 300 meters separation, 10 solos. If we had groups, then obviously we'd need to leave a little bit extra. So that's 1.6 nautical miles. One thing I find people really don't have a concept of is how much of a distance 0.2 nautical miles, 0.1 nautical miles, half a nautical mile is when we're talking about spotting. So for the experienced guys, a useful little tip, this distance at Langer, one of these little sections of the triangle, is 0.2 nautical miles. So if you're ever thinking that the spot needs to be a little bit deeper, or you're thinking, how far past is the spot? If someone says the spot is 0.4 past, then you're looking at 2 of those distances past the overhead if we're looking at 0.4 past. If we're looking at 0.2 before, then it would be 1 of those distances before the overhead. So that's a useful little measuring stick or reference to have in your mind. So basically, we come up with all those numbers. We choose what our reaction time we want to have, and we work out how far across the ground we're going to move for a given ground speed. And we come up with a table that looks a little bit like this, that tells us how many seconds we need to wait between exits to give us that amount of meters we've chosen between groups. This is a table that quite a few of you, if you've jumped at Langer, will have came up with, and the distances in the table there are all in meters. So in the green there, we see we've got, in the brightest shade of green, 310 meters, 342, 357. They're all about 350 meters. So that was about the spacing we were working to for solo groups. And as we move up into the too long, the yellow side, the separation moves up into the 400, 500 meters sort of range. And if we move down into the red, it moves to a lesser number. To help you apply this as an experienced jumper, if you look at the bottom bit there, the simple side of it, the ground speed, what I'd recommend you do is just try and memorize one of those numbers. So for example, for a 70 knot ground speed, we need 10 seconds separation. If you pick any of them and memorize it, so 70 knot ground speed, 10 second separation, and then all you need to do to go either way is plus or minus a second. So if you know that 70 knots is 10 second separation, then you can work out that 80 knots is 9 second separation, because we're just plussing and minus seconds depending on which way we're going. You're not always going to have that reference sheet available to you in every aircraft you get in, but if you remember one of the lines, you'll always be able to work it out for yourselves. That's a useful thing to be able to do if you're a more experienced jumper, someone who might more often be the jump master, for example. So even if you don't have that information to hand in the plane, you can work it out by looking at the GPS. So by a quick show of hands, how many of the guys there have ever tried to read the pilot's GPS? Sure, some of you do. It's a really useful thing to be able to do, providing you know what you're looking at. So this is the exact GPS model that we actually have in the aircraft at Langer. The number in the bottom left there is the ground speed. So in this example, the aircraft's traveling at 127 knots across the ground. And the distance in the bottom right is the distance to the waypoint. So at Langer, we would have that set to the overhead of the drop zone normally. So by reading that ground speed, you should be able to work out the exit separation you need if you have a concept of one of those numbers. But that comes with a caveat. If you're not exactly sure of the number you're reading, your pilot might give you a bit of a look like this. I've genuinely had it when I've sat there flying and I'm flying crosswind on the way to altitude. You know, I'm not even lined up with the jump run. I'm still in the climb. I'm at some random airspeed, and someone's looked over my shoulder and gone, "Oh, we're flying 110 knots ground speed. It's this much separation." That ground speed doesn't mean anything until we're configured on the jump run with our flaps down and we're flying the direction we're going to be flying when we jump out. Hopefully that makes sense to everyone. If we're flying downwind, our ground speed isn't going to be the same as it is when we're actually flying in the correct direction with our flaps in. So if you're going to try and read stuff off the GPS, I'd encourage you to do it and use it as a tool, especially for the experienced guys, but make sure you know what the numbers you're looking at mean and how they fit into your full spatial awareness of what's going on at that point. So after we know that exit separation, what it should be on our load, if we know for a day, for example, that it should be 7 seconds separation given on the ground speed for jump run, then our jump master should be applying their experience to work out what the actual number should be. Just using the number you get off the table should work, but a good jump master is going to use a bit of their experience. If you've only got a few groups on the plane, then obviously we can add a few seconds. You know, we don't need as much separation if we've only got a few, we can have more separation if we've only got a few groups to get out of the aircraft. And if we've got loads of groups, we've got lots of solos, then we don't want to be adding extra. If anything, we want to be getting on the closer end of where we can physically get. It can be as dangerous to be exiting the aircraft a long way away. When we're exiting the aircraft further from the drop zone than we should be, that's when we're getting ourselves into situations where we start to make low turns, mistakes trying to get to the drop zone. So the way to avoid that, either don't exit if you're too far away, and do your absolute best to get everyone out in a reasonable time frame as you can. When you land, how we start applying this factor, if you were too close, if you felt like you were pretty close to the group before you, then tell drop zone control so we can start to adjust that. If you felt like you couldn't get everyone out of the aircraft in time, you were flying too fast over the ground, again, tell drop zone control, pass the information around so we can work with each other, adjust the separation as needed. So to give you an idea of those fudge factors from the previous slide, you can see on this table at the top part, it's not a definite number. We can move up into the yellow if we've got more wiggle room, if we've not got many groups. And we can move down into the lighter shade of green if we feel that we've got lots of groups to get out. Give everyone a chance to read the meme. So doing your bit as a jumper on the aircraft, firstly, just know the number. Before you enter the plane, know what the separation should be. Quite often you get people asking in the aircraft. You can find that number out from drop zone control. It's part of preparing for a jump. And then as a jumper, know that it's the time between exits, not the time from when the previous group climbed out, jumped until you climb out. Okay, if you do that, you're going to add another 5 seconds. We're nowhere near the correct number at that point. So if it's a 7-second separation and you know that you've got a lot of stuff to set up in the door, you've got a complicated exit, then start climbing out on the 2-second mark. Know who's before and after you. If you've got a massive group before you, there's a 14-way jumping before, and then you're doing a solo, second, you know they're going to be tracking a long way, so leave a few more seconds than you need to. And if you don't feel comfortable with that, ask the guys in a bigger group what separation you think you should leave. They think you should leave. And lastly, spot. This is all well and good, but quite often you see people just getting in the door and jumping without even looking down. At a bare minimum, even if you don't know what you're looking at when you look down, I would encourage everyone just to get in the habit of sticking their head out of the door and having a look. Even if you're a console student listening to this, before you jump, just stick your head out the door. Get used to the feeling of the wind on your face, look down, see where you are over the ground, and then set yourself up and jump. Does anybody have any questions on exit separation? Stick your hand up if you do. Doesn't look like anyone does.
Josh, a couple of times you spoke about being overhead of the drop zone. I was wondering, at Langer, because it's quite a big drop zone, does that mean the very centre cross or the centre of the landing area that's just out front of DZ control?
Yeah, normally we reference the landing area at Langer to being overhead.
Awesome.
Cool. I'll keep pushing on there because this is not taking longer than I thought, but that's the serious, useful information of my talk. And the next bit is the more contentious, off-the-cuff comments, which everyone's actually here and wants to hear. So let's talk about electric planes. There was a really good talk that Brian and Pete organized the other day about sustainability. And I think it is something we really need to think about in our sport. So don't get me wrong, I'm not saying that we shouldn't put any effort into thinking about sustainability. I absolutely should. We should. I just think we need to focus our efforts into the right places, especially what we can do in the short term as well. Electric planes come up a lot when you start talking about sustainability and skydiving. People talk about them a lot. And I think it's really interesting technology, but I want to just give a bit of insight, perhaps from a jump pilot's point of view, from a drop zone owner's point of view as well, about why, well, I'll come on to that. Why it'd be awesome to start off with. There's the potential to use renewable energy. We could have solar panels on our hangar roof. They could be charging a spare battery pack through the day. So we're not burning any CO2 through that. And if we are charging them with our own solar panels, then we could be getting free energy into our batteries as well. That's why they would be awesome. It's why people are excited about them, rightly so. There is excitement about the potential for electric flight. We could have increased performance. Electric motors, everybody's seen the videos of the Teslas doing launch control. It would be the same in the aircraft. You push the power lever and you'd get pretty much instant power. The same thing in an aircraft should stand true. Unfortunately, I think electric planes are a little bit of a red herring. I think they're a bit of a distraction for us from the bigger picture of sustainability in skydiving and flight as well. I think they're a while away for skydiving. I think even until we see them being tested in our industry, it's probably about 10 years. Here's some of the reasons why. People say skydiving would be an ideal case study for electric planes because we have short flights. Now, although all the individual flights are short, we sometimes don't shut down for an entire day. So actually our industry doesn't really have short flights. The engine's turned on for an entire day, which would mean we would need to be pulling power battery for an entire day. And the normal response people come up with for that is you could have changeable battery packs. So you could have a battery pack, you do your one flight, you land, you take your battery off and you put another one on and off you go. It's a sound theory, but a battery would be a key component to this aircraft being able to fly. You'd have to change it in the field, so you land and then you're taking this battery off and you're putting another one on. And there's no precedent for that in aviation at the moment. If you're taking components off an aircraft and you're putting more components on or a different component, you need an engineer to do that, someone who's licensed. You'd need a work order. There's all kinds of regulation and stuff in the way of doing that. It's not to say that it can't be done, but I'm just saying that aviation, the industry, it moves fairly slowly. So the barriers that need to be broken down for that to be able to happen, they're not small barriers and they'll take time to overcome. Drop zones like caravans. Drop zones rarely buy new aircraft. They're normally on a second-hand market looking for caravans and other aircraft that they can use for their activity. Caravans are a really good skydiving plane. The maintenance is fairly cheap. They can carry a good capacity. They're really fuel efficient compared to other aircraft out there. And I say that just to say that we're probably going to be looking at when we eventually look at electric aircraft, we're going to be converting a caravan to an electric motor. Some of you might be familiar with the Magnix aircraft, which is a really cool project by a company called Magnix to look at put an electric motor in the front of a caravan. And they've flown this aircraft. It's not some far-flung research mission. They've put a motor in a caravan and they've flown it. So why is it that I think it's still a long way away for skydiving? A little bit of a weight difference. That's a Pratt & Whitney PT6 140 on the left, the same engine that the Langer aircraft have in. And on the right is the Magnix 500, which is their 500 kilowatt motor and the little driver that goes with it to make it huge. So the Pratt & Whitney engine is 225 kilos and the electric motor is 145 kilos. So you get an 80 kilo saving just on swapping engines. I'm ignoring wires and stuff because I don't have any data for that, but let's assume that their wires don't weigh much. We'll give them that benefit. The big problem comes down to batteries. Elon Musk, who probably knows a little bit about batteries, says that a 400 watt hour per kilogram battery should be available in 3 to 4 years. He said that in August 2020. So in 2024, we might have a 400 watt hour per kilogram battery. And this is referred to as energy density. It's the amount of energy that we have for a given weight of battery. 400 watt hours per kilogram. That's a lot for batteries. The technology is moving fairly fast. And just to put that in context though, jet fuel has an energy density of 12,000 watt hours per kilogram. Someone correct me if I've said that wrong, but it's a lot higher. Now, one thing that people don't always give fairly to electric motors is the fact that they are much more efficient than internal combustion engines and turbines. Electric motors are about 90% efficient. Internal combustion engines are quite a bit lower than that. It still stands, however, that at 90% efficiency, to produce 1 kilowatt hour, you'll need to be carrying 2.8 kilograms of batteries with you on the aircraft. SFC is the specific fuel consumption, so that's a number that you can get for a Pratt & Whitney. A PT6, that's the engine that most skydiving caravans have in at the moment, is 0.4 kilograms per kilowatt. That's the amount of fuel you need to be carrying with you. To produce 1 kilowatt hour, you'd need to be carrying 0.4 kilograms of jet fuel. So to put that in context of a load, for one load, 17 minutes of flying at full power, you'd need to carry 57 kilograms of jet fuel with you. That's about right. And to fly one load with batteries, 17 minutes, you'd need to be flying with about 397 kilograms of batteries with you. And that's in 4 years' time by Elon Musk, a guy who should know a little bit about batteries. The other problem is not only would you have to carry that fuel, the additional weight, for batteries, you'd have to carry it for the entire cycle. Our engines at the moment are quite efficient at turning the fuel into H2O and CO2 and throwing it overboard so that you don't have to carry that weight around with you. In the case of batteries, you have to carry them for the entire duration of the flight. I'm just going to pause for a second and read the comments because I'm seeing a few in. I'm slightly scared that I've done my maths wrong. It's been a while since I did engineering, so I want to see what people are saying. Yeah, so I think people kind of get the idea that basically batteries are heavy at the moment. Now the technology is moving fast. I don't think it will be a long time before it's reasonable. And don't forget that you get potentially an 80 kilogram saving through not having to carry the turbine with you on your electric motor, providing the wires don't weigh anything, but they are still heavy. Aviation is much more weight sensitive to other industries. That's the reality of it. You know, our aircraft are made out of aluminium. They're designed to be light so that they can climb quickly. They're affected drastically by any increases of weight. The electric vehicle industry is moving much faster in other areas. So those pictures there, the excavator is all powered by electric. Now, an excavator could even be plugged in with a wire. So, you know, that's going to move a lot faster than the aviation industry can. The pickup truck at the bottom is called a Rivian. It's something that Amazon have invested in. I think it's really cool. I can see a day where Langer is driving people out to the runways on one of them instead of our Mitsubishis. I think that's a little bit more realistic in the short-term future. So what can we do now? Solar power is something that's a little bit more in the short-term grasp for drop zones. I think we should aim, you know, I'm not saying that it is going to happen, but I'd love to see more drop zones having solar panels on their hangar roofs and trying to use that as renewable energy. I don't blame any drop zones that don't, you know, it's a big investment. The government's taken away a lot of grants that would help make that happen quicker. Electric cars, it's kind of, it's unrealistic to think that any of the aviation sector is going to be using electric planes before everyone is driving to a drop zone in an electric car or driving to an airport in an electric car. Electric cars are going to move a lot faster than the aviation industry will. So I wouldn't expect to be seeing electric planes anywhere until you're sat in an electric car. What we can do better at Langer, I'd love to see us recycling more. Some of you guys might know how difficult it is for us as a center to recycle. I've made this point in the sustainability meeting. Oh, I've got 10 minutes left apparently. I'll talk really fast. Veolia, who's the biggest waste provider in Nottinghamshire, basically told us that they're unable to do mixed recycling at our location because we're too far out in the sticks, which means that we can't recycle aluminium cans. We can't recycle glass. We can recycle cardboard, but if you actually look into what you're allowed to put into a cardboard bin, it's not very much, which is a bit of a sad state of affairs. And I think that's actually something that needs to be government-led. They need to make it easier for companies to be recycling. At Langer, we actually collect our own aluminium cans and we take them to the scrap collector, so at least they're staying as aluminium instead of being put into landfill. Industry-wide, then, the thing we should be looking at, especially in aviation, is biofuel or alternatives to that. Because it's renewable effectively, instead of dinosaur fossils coming out of the ground, we're growing things that can be turned into biofuel that our aircraft can burn as they are. And also when you're growing the plants absorb some CO2. So in summary, electric aircraft are not in the short-term future for skydiving. I think that's important for us to realize, because we need to focus our efforts elsewhere. It's easy to think, oh, electric aircraft are coming, let's stop worrying about sustainability. And the reality is we need to think about other things. We need to be figuring out how we can get electric cars out to everyone, how we can be using renewable power to power electricity at drop zones, instead of thinking that electric aircraft are going to save us from our woes.